All right, in this video, we're going to go through 2.C standard exponent rules with so that's the DeltaMath assignment you're working on. And I'm just going to work through a couple examples of each problem so that way you guys know how to plug in your notation and answers correctly and make sure you're doing your work right. All right, so let's do this. It says express the following fraction in simplest form using only positive exponents. So I have, 3u to the fifth over 2 times u to the fifth okay? And then we're going to start simplifying that. So a couple of things I tend to look at first are my coefficients, so my numbers that actually appear here. Can I simplify 3 over 2 at all? They don't have any exponents acting on them, so I don't have to do anything with them first. And 3 over 2 actually is as simple as it gets, right? They're not both divisible by anything, so 3 except for 1. So 3 over 2, my numbers are going to stay exactly the same. I have parentheses down here, so I'm actually going to simplify this step next. So I have u to the fifth to the fifth, and so that part is going to leave me when I have an exponential expression to another power, a power to a power, you multiply those. So u to the fifth times 5 is u to the 25th. Okay, and then like I said, my 3 over 2 didn't change at all, and then my u to the fifth up top didn't change at all. So we're in this step. And then now I ask myself the question, because I notice I have u's on both the top and the bottom. Where do I have more u's? Hopefully we say on the bottom. How many more do I have? I have 20 more on the bottom. So 5 of them on the top will cancel with 5 of them on the bottom. And my final answer will be 3 over 2 u to the 20th. All right, so then I can do 3 divided by 2 u to the 20th, just like that. Voila. All right, let's try another one. All right, for this one I got 5y over 3y to the fifth squared. Okay, this time, let's see, I notice I have my 3y to the fifth is all being squared. Can I distribute this exponent? Absolutely, because I don't see any addition or subtraction happening. So I'm going to go ahead and distribute that exponent first. When I do that, my 5y on top stays exactly the same. And then in the bottom, I will have 3 squared. And then when I do y to the fifth squared, that's an exponential expression to another power, a power to a power. So I go ahead and I multiply the 5 and the 2. So I'll end up with y to the 10th on the bottom. Okay. Then we're going to do a little bit of simplification with my coefficients. So 5 is on top, and then 3 squared I know is the number 9. So I'll have 5 over 9, and then those don't reduce at all. And then for my y values, since I have y's on the top and the bottom, you have to simplify those. So where do I have more y's? On the bottom. How many more? 9. So I'll end up with just 9 y's on the bottom. So I have 5 over 9y to the 9th. And there we go. All right, so those are the first level. Let's go ahead and go to level 2. We'll do a couple of those ones. So these ones look like they're throwing in some nice negative exponents for us. So I have 2 times r to the negative 2 to the fifth power all over 2r to the negative 6. Okay, up top, first thing I notice, well, actually, first thing I notice is that when I look at my coefficients, 2 over 2 reduces, right? 2 over 2 is the same thing as the number 1, so those will actually kind of just cancel out, right? Because I'd just be left with 1 over 1. And then on top, when I have r to the negative 2 to the fifth, when I have a power, an exponential expression to another exponent, a power to a power, I go ahead and multiply those together. So I really end up with r to the negative 10th on top, negative 2 times 5, and then r to the negative 6 on the bottom. And then we know that when exponential expression has a negative exponent, they're currently living on the wrong side of the fraction, so these guys are actually going to flip spots. So I'll end up with r to the 6 on top and r to the positive 10 on the bottom. Okay, now we're going to reduce. Where do I have more r's? On the bottom. How many more do I have? 4. So for this one, when I write my answer, I'll end up with 4 r's on the bottom, and then what number is on top? Well, it's the secret number that is always technically multiplying, right? I have my 1 on top still. Don't just, because I have more r's on the bottom, you can't then just have them be on their own. They have to still be in the bottom of a fraction. The number that just goes on top is the number that's always secretly there. 1 over r to the 4th. There we go. Okay, let's go ahead and try another one. In this one, I have a lot of things going on, but it's all right, we got it. So I have parentheses 3k to the 4th to the 5th power, all over negative 15k to the 10th. And so then I'm going to go ahead, and first thing I notice is I have a couple of things to an exponent. So can I distribute that exponent? Absolutely, because I don't have addition or subtraction anywhere. So when I distribute that, I'll end up with 3 to the 5th power. And then when I have an exponential expression to another exponent, I have a power to a power, I go ahead and multiply those exponents together. So k to the 4 times 5 is the 20th. And then on the bottom, I have negative 15, and then a k to the 10th. Oops, those should still be in the color because we didn't do anything with those. Negative 15, and then k to the 10th. Okay? All right, so 3 to the 5th, if I do 3 to the 5th, it's really just doing 3 times 5, or excuse me, 3 times itself 5 times. So 3 times 3 times 3 times 3 times 3. So I get 243. On top, and then I have k to the 20th. Oh, excuse me, 243 on top, negative 15 on the bottom, and then I also have some k's. Some k's I can simplify. So where do I have more k's? On the top. How many more? 10. So I'll end up with 10 k's on top. And the last thing you want to double check is your 243 divided by negative 15 to see if that reduces at all. And it does. I just might have to get out my calculator to check on it. And your 243 over negative 15 reduces to 81 over 5. Whoops, so this case up there. In your calculator, if you ever want to reduce a fraction, you can do so by, once you put in this problem, so like 243 divided by negative 15, when I did it in my calculator, I got the decimal 16.2. And then if you hit these buttons on your graphing calculator, so math, it's over underneath your alpha key, and then you press enter twice. So enter, enter. Your graphing calculator should spit out the reduced fraction, or the most simplified fraction of 16.2. So that's how I knew it was 81 over 5. Oops, forgot to put my case up there. What the heck? So I did something wrong. Let's not panic. All right, double check our work. So let's see, 3 to the 5th is indeed 243. K to the 4th to the 5th is in fact k to the 20th over k to, oh, I forgot it's negative. Oh my goodness, you guys, that's an easy fix. All right, 243 divided by negative 15 would give me a negative 81 over 5, just like it should give me a negative 16.2. Goodness gracious. Okay, cool. So that's how you do those problems. And now let's go back. I'm going to do some level 3, which is just going to be more steps. And so it's very important that you have, like I said, the scratch paper, because you want to keep track of everything that's happening. All right, so in this one, I have 3x to the 10th, c to the 10th, all over negative 4. And then x to the 3rd, c to the squared, to the negative 4. All right, right off the bat, 3 over negative 4, nothing else is happening to those, and those can't reduce, so I know those will actually be my very final numbers in my answer. I'm going to go ahead and on the bottom see if I can distribute this exponent, and you absolutely can because there's no addition or subtraction. And so then really you end up with x to the, when you have an exponential expression to another power, it's a power to a power, so you multiply those numbers. So 3 times negative 4 is negative 12, and then c to the 2 times negative 4 is negative 8. And then on top, I still have my x to the 10th, c to the 10th. Now these guys are currently living on the wrong side of the fraction because they have negative exponents, so I'm going to go ahead and scooch them both up there. So I'll have 3x to the 10th, x to the 12th, c to the 10th, c to the 8th, all over negative 4 is the only thing that's left on the bottom. And then since you can multiply the exponential expressions that have the same base, and then you can add their powers. So I'll have 3 and then x to the 22nd, because 10 plus 12 is 22, and then c to the 18th, 10 plus 8, and then on the bottom my negative 4. So 3x to the 22, c to the 18th, divided by negative 4. Beautiful. All right, let's try another one. All right, so in this one, I have 5 times t to the negative 4th, x to the negative 5th, to the negative 1st, all over 3t to the 4th, x to the negative 1. My 5 over 3, nothing else is happening to those, and that's as reduced as those actually get, so you'll have a 5 over 3 like that. And then you're going to go ahead and see if I can distribute this exponent, and I absolutely can because I have no addition or subtraction happening. When you have an exponential expression to another exponent, a power to a power, you go ahead and you multiply those. So I'll end up with t to the negative 4 times negative 1 is a positive 4, and then x negative 5 times negative 1 is a positive 5. On the bottom, nothing happened down here, so my t to the 4th and x to the negative 1st power. I notice that this guy is currently living on the wrong side of the fraction, so I'm going to go ahead and scooch him up there. So I'll have 5 t to the 4th, x to the 5th, x to the 1st, all over 3t to the 4th. And now we'll combine my x's and t's. So my t's, you're looking at, I have some on the top and the bottom. Where do I have more t's? Oh, I have equal amounts of t's. So actually, if you have equal amounts of t's, they're just going to end up canceling. You won't be left with any t's anywhere because the 4 t's on top would cancel with the 4 t's on bottom. But I do have x to the 5th times x to the 1st, and so when you multiply exponential expressions that have the same base, you add your exponents. So I end up with 5x to the 6th on top, 5 plus 1, 6, over 3. Awesome. All right, so those are the standard exponent rules assignment, or that is the standard exponent rules assignment. Let me know if you have any questions.